Welcome to yet another creative excursion, which may lead somewhere or nowhere. Today, we are revisiting the Arduino platform and building a thing. At least I have some... Chill out, phone. At least I have some idea of what that thing will be. It will be squinting into the sun. I use the Pomodoro technique vaguely. I operate pretty well with repeated annoyances and reminders. So it's one of my favorite things about the Cortana app is that it gives very persistent... Sheesh, is this thing getting looser? First of all, it's very easy to get reminders recorded. Very easy. The voice to text is very good, and it accepts human or English language format. You know, next Thursday at 10 kind of thing. In 2 weeks. Stuff like that. Things that are easy to verbalize or vocalize. And the Wednesday after this one or something like that. But my second favorite thing is the reminder system, because the reminder pops up and it immediately gives you the option on the first page. So it pops up on that reminder screen, and the reminder screen is delay 15 minutes, 1 hour, 4 hours, 1 day. Those are your options, one button push away. Perfect. So I have the option of saying I want to be annoyed by this in another 15 minutes, because my rule is I don't clear any alarms unless I've actually completed the task. So even if I'm in the process of doing it, I don't clear it. This means that the alarm stays very persistent and keeps me on track, because I can work very single-mindedly, but I can also get distracted and then focus on a distraction very single-mindedly. So that's very helpful. The Pomodoro timer, especially with the ticking, makes it a lot easier to not lose track of time. Losing track of time is my big downfall, because I'll get stuck on something and then, you know, an hour has passed and it wasn't even that important. And if I would have known I'd been working on it for an hour, I would have just done it the easy way or the dumb way, just to get it done, because you want to make it perfect and you just can't. Something like, ooh, that's interesting. Something like, you know, the next chapter in my book, I'm going to finish an outline of what happens in the chapter in 25 minutes, which is a standard Pomodoro timer. So within 25 minutes, I'm going to finish the outline of the chapter. So you spend 15 minutes on the first paragraph, and then you go, tick-tock. This ain't going to work. You're like, oh, dang, I gotta get on this. And then your next paragraph is, and then this happens, and then that happens, and then he feels like this, and then he goes there, and then they go here, and then end of chapter. Cool. You finished the chapter. It's a rough draft. You can come back. You got all your ideas out. You can polish it later, but you did finish the chapter. So the idea that ticking clock really pushes you. It helps, and it works well for me, and you can even see it in my live stream coding sessions, where I start to run out of time, and then I'm like, let me hurry, 3 minutes left, 2 minute left, you know, it does work for me. Because I am not very, well, talk about that another time. So the idea is that, so I have this Walmart, I have a number actually of kitchen timers, or Pomodoro timers basically. And the idea is that they be set to it's just a regular clock timer. You know, it's like an egg timer. So it ticks down from the time that you set it, and then it rings, and then that's it. My problem is that after it rings, you know, if I'm in the middle of a thought or in the middle of some code, my answer is, okay, well, let me just finish this line of code. And then let me just finish this line of code turns into, well, let me just finish this function. And then before you know it, the ringing is forgotten, and I'm working through it. It's been an hour. I'm wasting an hour on it. I've also found that when I continue working past the 25-minute mark, I start to make mistakes. And then it takes me like an hour to track down the mistake. So the 25 minutes and then a 5-minute break, very successful, very good, very efficient. But like I said, I don't get a good stopping point. So I did manage to find one kitchen timer that has not only a count down, but a count up after it's been finished. So it counts down and then it counts up, and it continually buzzes. You know, there's a break. It rings for the first, you know, few seconds of time's up, then it starts counting up the amount of time that it's been late, and then it'll buzz or vibrate or beep every, you know, few seconds, just as a reminder that you are overdue. And then you can look down at the timer and see that you're 5 minutes overdue, so you know that you haven't been just really quickly finishing this, you've really just been wasting time. So that's the function I want to implement. I want it to do that. But I have this Walmart timer that's very nice, very good design, very cool, very nice package. But it's just terrible. You know, the internals are all sloppy. When you turn the dial, it doesn't quite line up. When it rings, it's like ding 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 ding, and then it stops. It's very short and not that loud, frankly. So my idea is to build an I've got these rotary encoders that I've been testing for use on keyboards or as input devices. And I'm arduinoing as hard as I can. There's a lot of weird timing because they're mechanical, they're not optical. The optical ones have no debounce, or have no bounce, but the mechanical ones do. So it's been a little bit weird getting the timing just right on them, and I think I've got, you know, you fiddle with the functions and the timing enough, you'll get some interesting results. So there's like a notch click, tick tick tick, and then there's like a half click, like a little bump before it drops into the click. It's very cool. It's very good. It feels very positive. It feels good in the hand. But it what that was. Yeah, there's another keyboard, that Dell keyboard with the media controls, and it has like a volume dial on it. That thing, I use those a lot because there were a bunch of them and they were throwing them out, and they had USB hubs on them, so I harvested parts. But I noticed that if you turn the volume control fast enough, it wouldn't register. Well, that's the problem that I'm running into here. It doesn't have any debounce, and technically it's a problem with the polling. So it's a little interesting. But by fiddling around with things and changing the read speed and kind of mix and matching the digital read with a direct byte level read, I guess it is. I got it so that when you turn, you know, 1 2 3 4 5 really fast, it counts up to 5 perfectly. But if you turn halfway clockwise, like that little half set, it counts up fast. So you can skip ahead by turning it halfway and then just do click a click click a click for your fine movements, basically. So that's pretty cool. Because the rotary encoder, the mechanical rotary encoder, is kind of difficult to keep track of. There's a lot of timing that you have to balance out with this, and I'm learning that it's not simple. But at least I'm beginning to understand it well enough that I can tweak things to either get what I want, or tweak things to try stuff that should have an effect, should have an impact, and then see what the impact is. So the idea is that I'm going to build that build the Arduino. Right now I'm using a Nano, but I guess I could use a, Trinket or something like that. It doesn't need that much output. The objective is to build an OLED display with a menu into the top of the case. So it's like this little cylinder with a flat top and bottom, and you turn it to set the time. So in this case, I would be gutting out the internals, mounting in the top half the Arduino, the OLED with a hole cut in the top. So on the top of the top would be the OLED display, and then the rotary encoder would have to be inverted, facing down, so the knob was facing down, and then the bottom would be basically the knob. So technically, I mean, that's the cool thing about the rotary encoder, is you can turn it 360 degrees, turn it infinitely, as much as you want. So then you don't have to worry about, so then you do actually have to worry about crossed wires. Because if I just use like a potentiometer, then the potentiometer maxes out at a certain degree, and then you have to go back or reset or click or something like that. Oh yeah, the rotary encoder has a click too. That's pretty cool. And it's a heavy enough click, and it's human controlled really. It's not rotary, so you don't really have to debounce it. Yeah, so the idea is that you can just set your time by spinning, probably holding the top and spinning the bottom to set the time, and you can count it up and count it down and get your time, and then push it together and you'll click it. And then when you click it, it'll set the time, and you'll have, menu controls and stuff like that. There's a low power version, and probably the first version is going to be plug-in, run at 5 volts off a USB. But I would like to have it so that it has a menu system for setting up Pomodoros, counting down. Technically, you're not supposed to pause a Pomodoro, but I want you to be able to interface with what's going on with it, so that you can change the times, set the times, count your Pomodoros, reset for the day, change your wait times, change your actual Pomodoro time, all that good stuff. And then turn on and off features like vibration, because I would like it to bzz, bzz, buzz around on your table. And then of course a speaker, a piezo electric speaker, to be annoying. But all of that's like, I don't want to say no moving parts, but the rotary encoder is the only moving part. So that's what I'm trying to build. But with some low power stuff, should be able to run it off a coin cell moderately well. We'll see.